Okay. So as now EDA stands for what? EDA stands for Exploratory Data Analysis. Okay. So in this EDA, basically what we are going to do, we are getting to know our data. Okay. What exactly is this EDA phase? EDA is nothing but getting to know your data phase. It is the process of looking at your data to understand what's inside that data before we do any analysis. Okay, before we give that data to a machine learning model so that it can learn from that data, or we start creating visuals out of that. Okay, first we should get to know our data. Okay, and that phase is called as EDA. Okay, in this EDA, what all do we do? In this EDA, we are going to structure the data, check the data set size. We are going to inspect the data types, what all data types are there. We are going to see that. Okay, and then we are going to preview the data. We see what are the first five rows, what are the last five rows using data.head and data.tail. And then in this EDA, what else do we do? We are going to handle missing values. We are going to check if there are any missing values. And then if there are any missing values, then we should decide, should we either drop that column or should we fill that missing values using either average, median, or what we should use. Okay, that is what happens in handling missing data. And also we do descriptive statistics. We calculate mean, median, max, standard deviation, all that. Okay, and then we also create visuals out of that. We are going to see box plot. We basically see box plot to highlight or detect the outliers. To see, we can create histogram to see how our data is spread across. Okay, and then we also create scatter plots, bar plot, all this. Okay, we are going to detect outliers, and then we are also going to fix these outliers, and then we are going to understand trends and pattern, and then we are going to ask questions about our data. All this is going to happen in EDA. Okay, so now, so here we will be working on a data set. Let me go to Google Colab. You guys can code along with me if you want. Okay, you guys can actually open your own Google Colab, and then you can start writing your code along with me. This, go to Python code. I'm going to send a dataset online.csv to you guys. Okay, you can actually download that, and then you guys can start doing along with me. Okay, how many of you wants to do hands-on? How many of you want to do it along with me? Type me in the chat. I just want to see how many participants me. Okay, great. There are a lot of participants who want to follow along. Okay, so as what you do, just open your Google Colab and just open a notebook. Okay, I'm going to send a data set to you. You guys can start working along with me. Okay, first let me load here. The data set is online.csv. That data set is very inconsistent, okay, which is not clean, which cannot be used or sent to a machine learning model. Okay, so first let me load online.csv. I'm going to send it to you guys so that you can use them as well. So this is the data which we are going to use. First, let me load it to my Google Colab. I'll click on OK. Now, as soon as I load the data here, I'm going to double click and I'm going to show it to you. See how this data is. Okay. In this, you're having order status is there, yes or no. And then monthly income of that person is there. Latitude of that person is there. Marital status, gender. Let me actually open this file and show it to you all, you guys. Okay, that will be better. Here, just delete this. Let me open online.csv. Yes, you can do it in Jupyter also. Yeah, here is the data set. Let me first explain it to you guys, okay, and then you can load it. Say here is this online.csv. In this, there is this unnamed column and then order status column. Monthly income of that person is there, okay, and then latitude and marital status of that person is there. Now, whether the person is male, female, that data is there, and then employment status is there, and what is the family size of that person, and did this person give a positive or negative review. Pin code of that person is there. If you see, age is there, but in this there are some missing values. We are going to learn how to fix this. In family size also there are some missing values, okay, and then education qualification of that person is there. Some column is there. If you observe, there is no column header. We don't have any column header, okay, and then this column is there where we are having column header 9, and then some column like this is there, okay. So we will be working on this. Let me send this data set in the chart. Hmm, let me just close this. It is not allowing me to send because it is open. Yeah, I've sent it. You guys can download this one. Yeah, I've sent this online.csv. Okay, once you have downloaded this, load it into your Google Colab. I'm going to remove this. Once you have loaded this, here I'm going to import all the necessary packages. So I'm going to import Pandas as PD, and then here I'm going to import NumPy as NP. I'm going to import from Matplotlib, import PyPlot as PLT. Okay, and then here I'm going to import Seaborn as SNS. Okay, here we need to load the necessary packages which are required. Okay, let me just send this. Guys, it's not opening. Download this one. First download it and then load it into your Google Colab. Okay, if you want to load, how you should load this first? You can simply click on files here, and then here you can click on this to load. Okay, fine. So guys, pay attention. Let me actually send this recording to you guys later. Okay, it's already a bit late. Fine, pay attention. I'm going to send this recording to you guys later. You guys can follow along and do it. Okay, pay attention now. So now first I have loaded this into my I've loaded this into my Google Colab online.csv. Now what I should do, I want to read this CSV file. How do I read this here? I'm going to do pd.read underscore CSV. And now here I'm going to copy this path. I'll click on copy path and then paste it here. As soon as I did this, I will be able to read this entire thing. Okay. This entire online.csv dataset, I'm able to read this. Now, what do I want to do? I want to store it inside a variable. So let's quickly store this inside a variable. Here I'll do df equal to, and then here I'm going to just print this data frame. Okay. So let's run this. As soon as I run, here you're able to see I've stored it inside the data frame, and now here when I try to print this, I'm able to see this entire data set is loaded here. Okay. Now how many rows are there? There are total 388 rows. There are 388 rows and then 16 columns. Okay. Right. There are 388 rows and then 16 columns. If you only want to see first five rows, you can do df.head. This will show you only the first five rows. Okay. And then if you want to see last five rows, you can do df.tail. If I now run this, see, we are able to only see the last five rows. df.head will give you the first five rows and df.tail is going to give you the last five rows. Okay. Now, what all things you do to inspect your data, df.shape. Okay, what this will do, this will tell you how many rows and columns are there. If I run this, there are 388 rows and then 16 columns in this. Okay. And then here, now what we should do, as we already know that this data is very inconsistent, right? There are a lot of missing values. There are a lot of outliers in this, which we need to fix. And then there are a lot of unnecessary columns. Let's fix this. Now, what do I want to do? I want to see what all columns have missing values and how many missing values are there. Okay. So for this here, I'm going to run this df.isNull.sum. What this is going to do, now this is going to tell me in each column how many missing values are there. In family size, there are 19 missing values. In age column, 19 missing values. And in this unnamed 13, 0 missing values. And there is this column 9. In this, there are 388 missing values. Okay. The total data set size is 388. And in this column only, we are having 388 missing values. And in this column, you are having 382 missing values. So in what all columns you are missing values? Family size, age, 9, and then this column, @something. Okay. Now, there is a common guideline in data analysis that if a particular column has more than 70% of the missing values, then you can completely drop that column. Okay. So now the total data set size is 388 rows. Out of that 388, now what is happening? Look at this 9. In this, 100% of the values are missing. Okay. In this column, 100% of the values are missing. And look at this column. In this also, almost 100% of the values are missing, right? So what we can do here, we can completely drop these two columns. Okay, we can completely drop these two columns. And also, what is happening here? Let me just open this data set and show you what all columns we can drop. We can drop this 9 column. We can drop this column. And if you notice here, there is this unnamed column. We can drop this column and also these 3 columns we can completely drop. So let's go ahead and drop these columns. So in this, let me see unnamed 13 is also there. Okay. If you observe here, let me just open this. Okay. This column is unnamed. And if you observe, okay, this column does not have a header. Okay, what is the column name? We don't know. So we can completely drop this column. Maybe you can ask the client what this column is. Even if he does not know, if he's telling that you can drop this column, you can go ahead and drop this column. So we are going to drop this column, and these 2 columns. Okay, because in this almost all the values are missing. So now how do we drop column? Here I need to do df.drop. Okay, here I need to run this code df.drop columns equal to, let's drop these columns. Here I want to drop this unnamed 0. So let me get this unnamed 0. I want to drop this column. I'll pass this here. And then unnamed 13. I want to drop this column, unnamed 13. And I want to drop this 9 column. And then here I want to drop this column, #%. Okay. All these columns I want to drop. Now when I run this, you'll notice that here I'm getting a result where all these columns are dropped. Okay. All the unnecessary columns we have completely dropped here. Now, did it make change in the original data frame? Let's see. Here, if I print my original data frame, in this, did you see unnamed 0? They're still there, right? Unnamed 13, 9 @. Okay, these columns are still there. So this is just showing us the result where all those columns are dropped. And then this is going to give us a new result, a new data frame like this. Okay. Now what we can do, we can take this result and update the original data frame. So here I'm going to df is equal to this. So now this is giving us a new result and that we are storing inside df. Now I'm going to run this. And now when I run this here, did you see here all of these columns are completely dropped. Okay, we have dropped all the columns. Okay. So how do we actually be sure that these columns are dropped? Here you can do df dot, you can do is null dot sum. Now when I run this, here this is a method. So parenthesis and close. Now when I did this, you can see those columns are removed. Unnamed column is removed. Okay. And then this column 9, unnamed 13, hash at the rate percentage, these columns are removed. Okay. All the unnecessary columns have been removed here. So if you want to actually confirm how last time, how many columns were there? 16 columns were there. We have removed 4, right? So here I'm going to do df.shape. After this, let me do df.shape. Now when I run this, here you are going to notice that what is going to happen. Did you see the column size is 12? 12 is the column, all the 4 columns, unnecessary ones. Okay. Was this clear to you guys? How did we remove the unnecessary columns? It was quite simple, right? Okay. So now next we are going to talk about imputation. Any idea what is imputation? So if you look at this df.isNull dot sum, df.isNull.sum. So now if you look at this, in family size, we are having missing values, and in age column, we are having missing values, right? We need to still fix those missing values. Okay. So the process of filling the missing values is called as imputation. Okay. Yeah, let me write it down here so that you guys remember. So there are two types of imputation, univariate imputation and multivariate imputation. Okay. There are two types, univariate and multivariate. Univariate imputation means what? That is actually inspired from statistics, right? Mean, median, mode, and all this is there in univariate imputation. Let me just put it down here only, somewhere here in this. Here I'm going to write imputation. Process of filling the missing values is called as imputation. Process of filling the missing values is called as imputation. There are two types. There are two types of imputation. First is univariate imputation. This is actually inspired from statistics. Okay, like mean, median, and mode. Okay, this is univariate imputation. Second one is multivariate imputation. Okay, this is actually inspired from statistics. Sorry, inspired from machine learning. Okay, in this your multivariate imputation, what all do we have? We have KNN imputation, and then in this we have mice. Okay, mice means multiple iterative chain equation. This is actually considered best in accuracy. Okay, right? So now what happens here? What happens? I'll tell you one example how we fill the missing values. Let's say that salary column is there. There is this column we are having values 2, 4, NA is there, and then 8 is there, and then 10 is there. Right. So now there is one missing value in this. Now what we will do? Now we are going to find the average of this. Now what is the average of this? If you do here, if you do 2 plus 4 plus 8 plus 10 divided by 4, how much are we going to get? How much will we get here? 2 plus 4, 6, 14, 24. 24 divided by 4. Here you are going to get 6, right? So we take this value and put it in place of missing value. Okay, this is one way of filling the missing values. Okay, so now what we are going to do. So in today's workshop, we are going to talk about univariate imputation. Okay, so now we go for mean and median. We go for mean or median to fill the missing values. So here, what did I do? Here I have found the mean. I found the average value and fill the missing values with the average one. Okay. First, I found the average value and then I have filled the missing values with this average value. Okay. Now like this, I should either find mean median. I should go for mean median when we have numerical values. Okay, now look at this. This column is a numerical column, right? This is a numerical column. In this case, I should either find the mean average of this or median and then fill the missing values with either mean or median. So basically we should go for mean or median when we have numerical values. Okay, and then here what is happening? We go for mode when we have categorical values. Okay, we go for mode when we have categorical values. Okay, now when we should decide whether we should go for mean or median. Okay, so here we know that when you're having numerical values, if you look at this age column here, I'm going to show you here df when I print this. So now if you observe, we are having missing values in what column? We are having missing values in family size, and then we are having the missing values in age column, right? We have the missing values in age column and family size. And what did we write here? What did we write? We should go for mean or median when we have numerical values. Now, in this case of family size, should I find mean or median? Or in this case, in this column age, should I find mean or median? What we should do? What we should do? Let's find out. Okay, so now here in this case what we should do, see, in this case here we should check outliers. We should check outliers first before we decide mean or median or numerical column. Okay, so now to detect outliers we use box plot. To detect the outliers, we are going to use box plot. So as now let's see if there are any outliers or not. How many of you have no idea what is an outlier? Put me in the chat if you have no idea what is an outlier. Let's create an outlier here. Me, okay, no problem. Outliers are actually quite easy to understand. Let me plot an outlier. Let me plot a box plot for age and age column and family size column. Okay, plt.figure. In this, I'm going to pass fixed size equal to 30,6. Okay, and then here I'll do plt.subplot 1, 2, 1, and I'm going to create a box plot. I'm going to create a box plot first for family size. Okay, so now when I run this, pay attention what happened. Here a box plot is created. Are you guys able to hear me clearly now? Am I clear now? Okay, great. So now here I've created this box plot. So now if you observe, there are no outliers in this. Okay, there are no outliers in this. And now I'm also going to create a box plot for age. So here I'll do plt.subplot 1, 2, 2. And then here I'm going to do sns.boxplot and do df of age column. Now when I run this, you'll notice that here what is happening. See, here I'm getting outliers. Here this box plot is actually showing me outliers here. Okay, let me actually explain you what is an outlier, what is a box plot. Let me show you. Okay, here I'm going to create a diagram and show you what exactly is this box plot, what it will do. Okay, so pay attention. I'm going to explain what is a box plot. So now look at this. This is how your box plot looks like. Here, something like this. Okay, if outliers are there, you will see circles like this. If you're seeing circles like this, it means that outlier is there. Now, if you notice what is happening here, this is a box plot. Okay. Uh, so this is the box plot for age. Now, if you see circles are there for age. For family size, there are no circles, which means that no outliers in this. Here we are having outliers. So what exactly is outlier? Outlier means circles like this. These are outliers. Okay. So now let's understand. Let's understand when when will you have box plot. Okay. When will you have box plot? Let's see. Okay. So now look at this. This point you're seeing, right? This point is called as Q3 or upper quartile. This point is called as upper quartile. And then here in middle, you'll get a line like this. In middle, you'll get a line like this. This is called as median. This is called as median. And this point is called as lower quartile. It is Q1. Q1 means lower quartile. This point is called as lower quartile here. And these are called as outliers. Okay. These are called as outliers here. Okay. So now here, this lower quartile you're seeing, right? This is 25 percentile. 25 percentile means what? What is the 25 percentile? 25 percentile means at this point, whatever values are there below this. Okay, this is 25 percentile, which means that whatever data is coming below this, that is less than 25%. Okay, and this is upper quartile, which means that here this is 75%. Okay, so now this is 75 percentile. Whatever values are above this are at least above 75% of the entire data. Okay. So now here, let me show you. Let's say you're having data like this: 4, 5, 6, 7, 8, 9, 10. Okay. Now in this, if I ask you what is 75 percentile point, 75 percentile point means this 7.5. So now this point is your Q3. This point is your Q3, and whatever values you're seeing above this, that is above the 75 percentile. Okay. So basically 75 percentile, you can say that 75% of the values are below this number. 75% of the values are below this point. Okay. This is your Q3. And Q1 means what? Q1 means 25 percentile. 25 percentile means somewhere here. 25 percentile point is this, which is 2.5. So now all the values which you're seeing in this above this point, okay, or you can say whatever values are lesser than this, that is, so at this point, whatever values are coming below this point, okay, whatever values are coming below this point are lesser than 25%. Okay. And this is Q3, which means that whatever values are coming above this point are more than 75%. This is your 75 percentile mark. And this 5 you're seeing here, right? Or you can say, Suppose there is a mark 5.5. This is median. Median means the value which is coming exactly in the center. Okay. 25 percentile means at whatever values which are there below this are less than 25%. And 75 percentile means what? Whatever values are there above this point, that is more than 75% of the entire data. That is your Q3 and Q1. Okay, median is there. And the difference between this you are seeing, right? The difference between this is called as IQR. Okay, the difference between this is called as IQR here, right? So now here we know that this Q1 is 25 percentile and Q3 is 75 percentile, right? So now you're seeing this mark here, right? Whatever values you're seeing which are below this mark, they are outliers. And whatever values you're seeing above this mark, they are outliers. Okay. Whatever values are there below this mark, they are outliers. Whatever values you're seeing above this mark, they are outliers. Okay. Now this point is called as lower limit. This point is called as lower limit and this point is called as upper limit. Okay. Now this point is called as lower limit and then this point is called as upper limit. This is Q3, which means that whatever values are there above this, that is more than 75% of the values. And this is 25 percentile, which means that whatever values are coming below this, that is less than 25% of the data. Okay. This is your box plot. This is your box plot here. And whatever values you're seeing above the upper limit are outliers and whatever values you're seeing below the lower limit are outliers. Okay. So now here, this point is called as lower limit and then this point is called as upper limit. Okay. So now what we should do, so now whatever less than this are outliers, right? And whatever more than this are outliers. So now we should find out our lower limit and upper limit. How do we find out lower and upper limit? What we should do, the formula to find out the lower limit is, here let me write down, lower limit is equal to, lower limit formula is Q1 minus Q1 minus 1.5 multiplied by IQR. Okay, this is the formula for lower limit. And what is the formula for upper limit? The formula for upper limit is Q3 plus 1.5 multiplied by IQR. This is the formula for upper limit. Okay. Here is the formula for lower limit and upper limit. Okay. Is this box plot clear to everyone? Did you guys understand this box plot and what is an outlier? Just put a yes or no in the chat. Okay, great. So now what we should do, we should detect here. We know that here, look at this. Here, there is some data. Here, this is your upper limit, right? Beyond this also, there is some data. And this is your lower limit. Okay, below this also, there is some data. But if you look at this, above this, there is nothing here. And below this point, there is nothing. That is how we know that there are no outliers in this. In this, we are having outliers. Okay, that is how we know this. Okay, right? Here we are detecting the outliers. Now what we are going to do, now we are going to fix the missing values in age and family size. Okay, we are going to fix the missing values in age and family size. So one important here, I'm going to write the observation in this text. Let me write the observation. Observation: family size does not have outlier and age has outliers. Okay, so we will use mean for family size. We are going to use mean for the family size. Okay, so what we are going to do, because family size does not have outliers, we are going to use mean. And then here what is happening, age has outliers. So we are going to use median in this case. Okay. So in case of age, we are going to use median to fill the missing values. But in case of family size, in this, because it does not have outliers, we are going to use mean here. And for age here, we are going to use median. Okay. So what we are going to do for family size, because there are no outliers, we are going to use mean to fill the missing values. Let me calculate the mean of family size. Here I'll do df of family size dot mean. Now when I run this, here you'll notice that mean value is how much? The average value of family size here is 3.2. Okay. The average value of family size is 3.2 here. Okay. Now here, so look at this. Look at this family size. So family size can be 5 or it can be 3 or it can be 1. Can we have family size as 3.2? Is it possible to have family size value as 3.2? Yes or no? If someone asks you what is your family size, you'll either tell 5, 6, 7, 8, right? Will you tell 3.2? No, we don't do, right? So what we will do, we are going to remove the decimal. How will we do this? We are going to pass this inside this int function. Now if I run, see, I'm getting 3. Okay, I'm getting 3 here. Now that we have find the mean, what we will do, we are going to fill the missing values. Here I'm going to store this inside the variable. Here I'll store it family size mean value is equal to this. Now when I run this, here family size mean value is this 3. Okay. Now what I'm going to do, if you observe here, there are missing values in family size. Family size 19 missing values are there. We are going to fill all the 19 missing values with this. So how do we do that? Here I'm going to do df of family size. Now in this, I'm going to apply this fillna method. Df of family size dot fillna. In this, here we have found the mean value, right? I'm going to pass it here. Now what this method is going to do, wherever there are missing values in this family size, all of them will be filled with 3. Now let's run this. Now here you'll notice that all the missing values are filled with this. Okay. But this change is not permanent. This is only temporary change. It is only showing us the result. Now if I look at the family size, see, in family size, missing values are still there. Now, if you want to make these changes permanent, what you should do, once you got this result, once you got this column where all the missing values are filled with the mean value, you should assign it back to that column. You here, this will get you the result. And then we are assigning this result back to the original dataset family size column. Now, when I run this, after this here, now when I'm running this, here you'll notice that all the missing values are fixed. How do we confirm? If I, here I'll do df dot is null dot sum. Df dot is null dot sum. Now when I run this, here you'll notice that, did you see? All the missing values of family size are filled. Earlier there was 19. We have filled all the missing values with this value 3. Okay, because this age does not have an outlier, sorry, because this family size does not have an outlier, we are going to use mean in this case to fill the missing values. Was this clear to everyone? How did we do it till here? How did we fill the missing values of family size? Yes or no? Yeah, we can use in place equal to true. We can do that also. Okay. Fine. Here we have filled the missing values. We have filled the missing values of family size. Now let's fill the missing values of age column. Okay. Now here what I'm going to do. Now because this age column has outliers, because this age column has outliers, what we are going to do here, we are going to use median. First, we are going to find out the median, and then we are going to fill the missing values of this age column. So whatever we are doing, we are removing the missing values. We are actually getting this data ready for a machine learning model. Before we send our data to a machine learning model, this is what we will do. We are going to fill the missing values, drop the unnecessary columns, okay, fix outliers. We are going to do all this, right? So here, let's find out the median value of age. How do we do that? Here we are going to do, here I'm going to write df of age dot median. Now, when I run this, here you'll notice that median value of age column is 24. So let me store it inside the variable age median value. And now when I run this, here you'll notice that here the median value of age is 24. Okay. The median value of age is 24. Now I should take this 24 value and fill all the missing values of this age column. How do we do that? Here I'll do df of age column dot fill now, and then age median value. This is going to give me the result where all the missing values are filled with 24, and then I should assign it back to the original column. Now, once I'm done, let's see if there are any missing values left. df, now here, this in age, we are not seeing any missing values. In family size also, we don't see any missing values, but we will confirm it using df.isNull, df.isNull.sum. We are going to confirm it using this. So now did you see here we have filled all the missing values of age column and family size column. Okay, all the missing values have been fixed here. Okay. Was this clear to everyone? Any questions you guys have? Why are we using sum? See, if I don't use dot sum, if I only show it like this, here it will show me values like this. In this, if there are any missing values here, it will show me true. Okay, if there are no missing values here, it will show me false. Okay, I don't want to see true or false. That is why dot sum will show you the exact number of missing values. That is why here we are doing dot sum. Okay, right. So now let's learn. Now what we are going to do here. Here we are going to see how to detect and fix the outliers. Okay. Now there are two techniques. Fixing outliers, here I'm going to write fixing outliers. There is two techniques, capping and trimming are simple ways to handle the outliers. Okay. So whenever we give our data to a machine learning model, we should make sure that we have removed all the outliers. Capping and trimming are the simple ways to handle the outliers. Okay. Now, first is capping technique. What is capping technique? In this, you set a limit. In this, you set a limit. Basically, we are setting a cap on how big or small values can be. Okay. So now what does this mean here? In capping technique, let's say that here this point, here let's say that this point is 75. Okay, or let's say this point is 90. Here you're seeing this, right? This upper limit, this point is 90. Any value beyond this 90, let's say this is 95. Any value beyond this 90 is an outlier. Here there is this value which is 95. In capping technique, what happens? You set a limit, you set a cap on how big or small the values can be. Here the maximum value, the highest value can be only of 90, but this is 95, right? So what we will do, we are going to convert this 95 value to 90. Now when this is done, there are no outliers left, right? That is what is a capping technique. So let's say the lower limit is 10. lower limit is 10, this value is 3, this value is 2. So now no value can be below this point. So this value will be replaced by 10 and this value will be replaced by 10. So in this case, once I've done, there are no outliers, right? This is called as capping technique. In capping technique, we set a bar, which means that no value can be below this or no value can be above this. That is what is a capping technique. Okay. That is your capping technique. Here, you set a limit on how big or small the values can be. Okay. For example, if upper limit is age equal to 100 and one person is having age as 150, this person age will be updated to 100. Okay, it will be replaced with 100. That is what is capping technique. Okay, and second method is trimming. This first is capping technique and second technique is trimming technique. In this trimming technique, what happens? You remove the outliers. You remove or you delete the outliers. That's it. That is what is trimming technique. Okay. In trimming technique, in capping, what happens? The outlier values will be replaced. This outlier value will be replaced with upper limit or lower limit. But in case of trimming technique, what happens? These values are completely deleted. Okay. In this, what happens? These values you're seeing, right? These values are completely removed. That is what happens in trimming technique. But often trimming technique is not used. Often we use capping technique only. Okay. Both methods help your data to be outlier free, right? So let's get started with our capping technique. Now, there are outliers. There are outliers in this age column here. SNS dot box plot. SNS dot box plot. Here, there are outliers in this age column. Now, when I run this, we are able to see there are outliers in this age column. Okay. Now we are going to fix these outliers. Now, how are we going to fix this outliers? If you want to fix the outliers in the age column, firstly, you need to find out what is your upper limit. This is your upper limit, right? And you need to find out the lower limit value. You need to find out lower limit. And then above this, above the upper limit is your outlier and below this lower limit is your outlier, right? So now here, what did I tell you in this? Here upper limit is Q3. Upper limit, sorry, this value is upper limit, and then this is your lower limit. And then this point is your Q3, and then this point is your Q1, right? So now what is the formula for upper limit? Here, let me just write it down. What is the formula for upper limit? Upper underscore limit is equal to Q3, Q3 value, okay, Q3 value plus IQR. Okay. Here, what is the formula? Here, I've written it down. Q3, Q3 plus 1.5 multiplied by IQR. Okay. Q3 plus 1.5 multiplied by IQR. Okay. And then lower limit formula is what? Lower limit, lower underscore limit is equal to here Q1, Q1 minus 1.5 multiplied by IQR. Okay. Now here, now what exactly is this IQR? IQR is nothing but the difference between this value is your Q3, right? This value is your Q3, this value is your Q1. Now the difference between Q3 minus Q1 is only your IQR. The difference between Q3 and Q1 is your IQR. Okay. That is what is your IQR. Let me write it down here also. What is IQR? And what exactly is this IQR? IQR is Q3 minus Q1 is your IQR. Okay. So now what we are going to do? Here we need to find out Q3, we need to find out Q1, we need to find out lower limit and upper limit. We need to find out all this. Okay. So here and here, as we have discussed, this upper limit Q3 is 75 percentile and Q1 lower limit is 25 percentile, right? So now we need to find out the statistical information of this age column. How do we do that? How do we find out the statistical information? Here I'm going to do df dot describe of age. So now when I use this method describe, it is going to give me all the statistical information of this age column. What is the 25 percentile of age? What is the 75 percentile of age? What is the maximum value? Okay, all this. So your 25 percentile is 23 and 75 percentile is 26, right? So this value is my Q1 and this value is my Q3. Okay. So here, let's actually store them inside the variables Q3 and Q1 value. I'm going to store it inside the variable. Here, what I'll do, here, let me create a variable Q1 is equal to, okay, Q1 is equal to df of describe, df of describe, uh, df dot describe age. In this age column, I want to get the 25 percentile. I want to get the 25 percentile. I'm going to pass it here. Now when I run this, inside this Q1, let's see what is stored. Look at this, here it is 23. 25 percentile is this value 23. Okay. So now let's also print Q3. Let's also print Q3 here. Q3 is 75 percentile. Right. So I'm passing this. What is Q3 value? Q3 value is 26. Okay. So now any value which is below this 23, any value which is below this 23 is an outlier, and any value which is above 26 is an outlier. Okay. Anything which is below this is an outlier and anything which is above this is an outlier. Now I also want to find out IQR. What did I say? What is IQR? IQR is nothing but Q3. IQR is nothing but Q3 minus Q1. IQR value is Q3 minus Q1. Here I'll print out this IQR. Now when I run this, IQR value is 3. Okay. So Q3 value is 26, Q1 is 23. So Q3 minus Q1, this value is 3. This is your IQR value. Okay. Now once we have done what we should do, now we have found out the Q1 value. We have also found out the Q3 value. Here we have also found out IQR. Now all we need to do here is, now we need to find out the lower limit and upper limit. Okay. Now here we need to find out the lower limit and upper limit. What is the formula for lower limit? Lower limit here is Q1 minus 1.5 multiplied by IQR. This is your lower limit. Let's find out what is the lower limit value. Here I'm going to write lower underscore limit is equal to Q1 minus 1.5 multiplied by IQR. Okay, this is your lower limit. So let's run this. Here our lower limit point is 18.5, which means that anything below this point, anything below this 18.5 is an outlier. And then, sorry, for I, this is my Q3, this is my Q1. And then here, this is my lower limit. Anything below this point, lower limit is this. Anything below this point is an. Okay. Let's also find out the upper limit. Here, the upper limit is equal to Q3 plus 1.5 multiplied by IQR. So here, let's print this upper limit and see. Here I'm going to print the upper limit. Upper limit is 30.5. Okay. Any value which is below 18.5 is an outlier. and any value which is above this 30.5 is an outlier. Okay. So using Q1, Q3, IQR, what did we do? We have found out the lower limit and we have also found out the upper limit. Okay. Was this clear to everyone? How did we detect lower limit and upper limit? Uh, am I clear now? Are you guys able to hear me? Is detecting lower limit and upper limit clear to everyone? Now, once we have found out the lower limit and upper limit, what we are going to do? Here we are going to use capping technique. We are going to use the capping technique to fix the outliers. Okay. So here what we will do, any value which is above the upper limit, any value which is above the upper limit. So now what was the upper limit? Here we have just found out here. So what was the upper limit? Upper limit value was 30.5, right? Upper limit is 30.5 and lower limit is 18.5. So upper limit is 30.5, upper limit value is 30.5 and lower limit value is 18.5. Anybody who has age more than 30.5 is an outlier. So all these three you're seeing, right? All these have age above 30.5 and any person having age below this 18.5 is an outlier. This person age is below 18.5. So this person is an outlier. Okay. So now we are going to fix the outliers using capping technique. So here, whatever their age is, this person age could be 33, this person age could be 32, this person age could be 31. All this age will be updated to 30.5. This is what happens in capping technique. All the values which are above this will be updated by the upper limit value. And here this lower limit value is what it is. Lower limit value is what? It was 18.5. So all the people who are having below the age 18.5, maybe this person age is 18. It will be replaced with 18.5. Okay, this is what happens in capping technique. Okay, so let's implement this. So implementing capping technique is very, very simple. All you have to do here is, here I'm going to, I'm going to df of age dot clip. Okay. So this is your capping technique. Lower limit, here I'm going to pass lower limit, comma, upper limit. Okay. So now when I did this, what is going to happen in this age column? Whatever outliers are there above the lower limit, they will be updated by lower limit value. And in this age column, whatever values are there which are above the upper limit, okay, whatever outliers are there which are above the upper limit, they will be replaced with upper limit. Now when I run this, here you'll notice that all the outliers are removed. Now we will not see any age which is more than 30.5 or will not see any age which is less than 18.5. Okay, so let me actually assign this back. Let's actually assign this back to the original data set. Here I'll do df of age equal to. Now after this is done, let's see if there are any outliers. Okay. So now how do we detect the outliers? SNS dot box plot. Here I'm going to do SNS dot box plot. In this I'm going to pass df of age. Now when I run this, you'll notice that, did you see, I'm not having any outliers now. All the values which are above 30.5, they are replaced with 30.5. And all the values which are below 18.5 are now replaced with 18.5. Like this, we have fixed all the outliers. Okay. Was this clear to everyone? How did we remove the outliers? So till now, we have removed unnecessary columns. Okay. We have fixed the missing values. And then we have also detected the outliers. Also, we have fixed the outliers. Okay. So guys, I'm going to send you this code. Okay, you will have access to this recording. Don't worry. Okay, I'm going to send this recording access so that you will be able to practice it at your own pace later. Okay. So till now, what all we have done? So till now, remove unnecessary column, remove unnecessary column. Okay, fix missing values, and then we have fixed outliers. This is what we have done till now. Okay, this is what we have done till now. Implementation of capping once again, sir. So how do we implement the capping technique? What we should do, df of age column, select this age column and then apply this clip method. And in this, just pass lower limit and upper limit, whatever we have found out, right? In this, we are going to pass lower limit as well as upper limit. Now, when we did this, here, what is going to happen? All the values below this lower limit will be replaced with lower limit. All the values which are above the upper limit are going to be replaced with upper limit. Okay. This is how, after this point, I'm assigning this result back to the original column. After this is done, if I now check, are there any missing values? Here we are able to see there are absolutely no missing values. Okay. Was this clear now? Any questions, any doubts? So guys, we are going to have class till 9:30. Okay, 30 minutes more. We are going to learn many more important things. Okay. What about others? Any questions, any doubts you guys have till here? Yeah, you can use that also. I need to check the code first. Okay. Let me check your code after this. So guys, now look at this. In this, there is a lot of categorical data, right? There is a lot of text data here. You're looking at this marital status, this is text column, this gender, this is a text column, employment status, in this you're having text, reviews is there, in this you're having text, okay? And this education qualification, in this you're having text. So now in this monthly income, in this you're having text. So now machine learning models, they don't understand text data. Okay. Machine learning models, they do not understand text data. So what you should do, when you give this data to a machine learning model, you should make sure that all the categorical data, all the textual data should be converted to numerical. Okay. There should be no text data. There should only be numerical. Okay. So now we are going to now learn how to convert this text data into numerical. What we should do for this. Okay. Here, this is called as encoding. Okay. This process here is called as encoding. Let me just write down. Here, encoding means what? Converting categorical data into numerical data. This is called as, okay. This process is called as encoding. Yeah. So converting categorical data into numerical data, this process here is called as encoding. Okay. So now when we do encoding, so now there are actually two orders in this. Okay. So text data are actually, they are there in two types of orders. First is nominal order and second is ordinal order. Okay. Nominal means which has no natural order. Okay. And then ordinal means which has natural order, which has natural order. Okay. So let's see. So now I'll explain you what exactly is a nominal column, what and then what is the ordinal column. Now look at this. See here. First, let me explain you an ordinal column. Okay, let me first show you what is an ordinal column. So now here there is this column called as qualification. There is this column called as educational qualifications. In this text data is there. We want to convert this to numerical. Okay, is this nominal or ordinal? Let's understand. Okay, here in this, okay, in this qualification, what a person will first do SSC, right? This is what he will do first, and after SSC he is going to do intermediate. This is 2. Okay, first he will do SSC, and after that he is going to do intermediate, and then here he is going to do BE. Okay, and then this is third, and then he will do MS masters, which is 4, and then he is going to do PhD. Now this has a particular order. This has a particular order, right? Now look at this. In this, you are having this column, education qualification. Did you see the person will first do schooling, and then after that he will do intermediate. After that he will do graduate. After that he is going to do postgraduate. There is a particular order. First this, second this, third this, like this. There is a particular order in this. Okay, that is what happens in education qualifications. This is an ordinal column, which has ordinal means which has a natural order. Okay, this is an example of ordinal column. Now let's look at nominal column. Nominal column means which does not have any order. For example, male and female is there. Do we have any order in this? That male first or female first, male second, female second. Do we have any order in this? No. So this has no natural order. So this comes under nominal column. Or let's say countries is there. India, USA, Pakistan, okay, China. In this also there is no particular order, right? So ordinal column means which has a particular order like this, okay? Which has a particular order, which has a particular order one after another. This after this we have something else. After this we have something else like this. But these two are nominal columns which do not have a natural order. Okay. So now these two comes under nominal columns, and this type of data comes under ordinal column. Okay. Is this clear to everyone? What is nominal column and what is ordinal column? Clear? So guys, now look at this and tell me which all are nominal columns, which all do not have any natural order. So look at this. Marital status is there. This is your this is your nominal column. This has no order. Gender is nominal column. This has no order, right? So now education qualification, this is what? This is ordinal column. Okay, and then this monthly income, then this can also be called as ordinal because no income is there. Okay, this comes under 1, and after this you are having 0 to 10,000. This comes second, and then some person is earning in between 10,000 to 25,000. This comes 3, and some person is earning in between 25,000 to 50,000. This comes 4. Like this, there is a natural order in this. Okay. So now some columns are nominal columns, some columns are ordinal columns. So now let's fix this. Okay. So here we are going to fix this one. We are going to convert all the text data into numerical. Let's start working on this. Okay. Now here what we are going to do, let's first work on gender column. Let's first work on gender column. Here gender column is text, right? How will this be converted to numerical? Let's see. Here gender column is there. In gender column, you are having male. Let's say here you are having male, female, male, male, and then female. Okay. So now how will you convert this to numerical? How are we going to convert this to numerical? See, this one column will now be shown in two columns, like gender male, and then gender female. Gender male and gender female. Okay, like this. Okay. So now this one column will be shown in two columns like this. Now here the person is male, right? So 1 year, this person is not female, so 0 year. Next person is a female, so year 0, year 1. Next person is male, 1 year, 0 year. Next person is male, 1 year, 0 year. Next person is female, 0 year, 1 year. Okay, like this one column will be shown in two columns like this. Like this. Now, even though if you don't have this column, even though if you only have these two columns, we are able to tell whether the person is male or female. Okay, if you look at this first person, here male is 1, female is 0, which means that this person is male. If you look at the next person, male is 0, female is 1, which means that this person is female. Okay, like this, when this column is divided into two columns. Now, based on this number, we can tell that whether the person is male or female. Okay. Did you guys understand this? How this text data is converted to numerical and how we can tell that whether the person is male or female? Yes or no? And this is a nominal column. This is a nominal column, which means no natural order, no order in this. Okay. Yes. So guys, now tell me, do we actually need two columns? Do we need these two columns to tell whether a person is male or female? Do we need two columns or one column is enough? No, right? We don't need two columns. Only one column is enough. Even if you don't have this column, only let's say if you only have this column, gender female is 0, which means that this person is male. Here female is 1, this person is female. Here 0 means this person male. 0 means male and 1 means female. Even this one column is enough to tell whether the person is male or female, right? We actually don't need two columns. So now we can drop the unnecessary columns as well. We should keep as low as less columns as possible. Okay. So let's learn how do we convert this gender column. Okay. How do we convert this nominal column into numerical? Okay. So now what we should do here, what we should do here, let me first see this. Okay, let's first see all the column names. Here I'm going to click on next. I'll click on next. Okay, df.columns. df.columns is going to give me all the column names. So in this, what all are nominal columns? What all are nominal columns which has no natural order? Here gender is a nominal column, and then marital status is a nominal column, and then employment status is a nominal column. These have no natural order. Okay, these have no natural order. So here we are going to convert this into numerical first, or we are going to convert this into numerical first. How do we do that? Here I'm going to do pd dot, here I'm going to do pd dot get dummies. This pandas is going to give us this method, which is get dummies. In this, I need to pass the data frame, the entire data frame. And then here I need to mention all the columns, which has to be converted to numerical. Here I'm going to pass gender column, and I'm going to pass marital status. And then here I'm going to pass employment status. Okay. Here I'm passing gender column, marital status, and then I'm also passing the employment status. Now, when I run this, here you'll notice that what is happening. Did you see there was only one gender column? Now I'm getting two gender column, gender female and gender male, like this. Okay. And now here for marital status, I'm having marital status married, true or false. Marital status preferred not to save. False, 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 you're getting. Marital status single, here you're getting false. Okay. And employment status, here you're getting true, false. Employment status housewife, here you're getting true, false, like this. Okay. But we did not want in this format, right? We did not want in this format. We wanted in numerical. So what we should do here, I need to pass d type. Here I need to pass d type is equal to, here I'll pass d type is equal to int 64. Now when I've done this, here you'll notice that, did you see? I'm getting the values in zeros and ones. Okay, I'm getting the values in zeros and ones here. Okay. So now here, if you observe, there are so many columns for this marital status. 1, 2, 3. There are three columns in this. There are three columns in this marital status. So now assume that here there are some people. So I'm going to have gender. I'll have a gender column here. The person is male, female, male, female, female, and others. Others is there. Okay. Now when this is converted to numerical, how it will be shown? Gender male. Here this person is male, right? So 1. So female 0. This 1. Female 0. Female 0. Others 0. Okay. Like this, here I've created a gender male. I'll also create gender female. Gender female. Male 0, female 1. Male 0, female 1, 1. And then others 0. Okay. And here this time 3 columns will be created because there are 3 genders, right? Male, female, and other. So here gender, other. Okay. Every time there is 0. Every time there is 0, only when it is other, here I'm going to have 1. So now in this, here I'm having 3 columns. Now my question is, do we actually need 3 columns to tell the gender of the person? No, we don't need 3 columns to tell the gender of the person, right? Suppose if I delete this column, if I drop this column, only these 2 columns are enough to tell the gender of the person, right? Look at this. In this last row, male is 0, female is 0. If male is 0, female is 0, automatically the gender is others, right? So here we actually don't need 3 columns to tell the gender of the person, right? So similarly, here if you notice, there are 2 columns to tell the gender of male, and then there are 3 columns to tell the marital status. We don't need all the columns. So here what we are going to do, here I'm going to pass an argument. Okay, I'm going to pass an argument here, which is drop first equal to true. Here, if I pass drop underscore first equal to true, what this is going to do, it will not keep all the columns. It will remove the unnecessary ones. See, here we had gender male and gender female. Gender female is removed. Marital status, there are 3 columns. The third one is removed. Okay. Like this, it will only keep enough columns to tell whether the person is male, female, or the marital status. Okay. Right. Is this clear to everyone? Was this clear? What about others? Yeah, at the end, I'm going to send this. Okay. At the end, I'm going to send recording and data set to everyone. For now, please just pay attention. Okay. Just listen to the class. You guys can practice later. I'm going to send the recording, as I said. Okay. Just pay attention. Only focus on understanding this. Later, you guys can do hands-on. Okay. Because already it's late. If I make you guys also do, it will become 11 o'clock, right? I don't want that. Okay. Right now here we have filled these columns with zeros and ones. Okay, so now let's also work on ordinal columns. Let's work on education qualification. Let's work on reviews, monthly income. Okay, let's convert these also into numerical. All these here are ordinal columns. Okay, does this affect the original? Yes. uh, Wait, let me show you. Yeah, that's a good question. Here I'll put df that this does not. Okay, this does not here. Here I'm going to run this. See, this does not. Okay, that was a good question. Here, once we get this result, I'm going to get this and I'm going to update my original data frame. Okay, let's run this. And then after that, df.head. Now, when I run this, here you'll notice that my original data frame is now fixed. Okay, Kirti, I hope you understood. Right. So now next in this, here reviews column is there. Here review positive, negative is there. Now we are going to fix this column. We are going to convert this text column to numerical. How do we do that? Let's see. Here, so now before we fix this review column actually have some unnecessary spaces. So here I'm going to remove those spaces. Here I'll do df of reviews dot str dot strip. Okay, it is. So this, what this will do, it is going to remove all the unnecessary spaces from the reviews column. So I'm going to store it inside the reviews. Okay, and then I'm going to do the same thing for other columns. For monthly income also, there is some unnecessary space. I'll remove that. So let me just do df.columns here. Okay, there is unnecessary space for monthly income. I'll get this. And paste it here also. And then there is unnecessary space for education qualification. So let me get the education qualifications part. Here I'm going to pass it. Okay. So I'm removing all the unnecessary spaces from these two columns as well. Okay. Now, once this is done, now this reviews is an ordinal column which has a natural order. Here I'll do df of reviews dot value underscore counts. This has a natural order. Now, when I run this, see, there is positive and negative. For positive, we are going to give 1, and then for negative, we are going to give 0. Okay. So we assign 1 for positive, and for negative, I'm going to assign 0. So I'm going to create a dictionary that, so dictionary, review dictionary is equal to, here I'm going to show for positive value will be shown as 1, comma, negative value will be shown as 0. Okay. And then what do I want to do? In the original data frame, all the positive values should be replaced with 1 and all the negative values should be replaced with 0, right? So here, what I'm going to do, df of reviews dot map. I'm going to use this map method. This map method you should use this map method only for ordinal column, which has a natural order. Inside this, I'm going to pass this reviews dictionary. After this is done, here you'll notice that all the positive values are replaced with ones. How many positive values were there? There were 317 positive values. All of them are replaced with 1 and all the negative values are there were 71 negative values and they all are replaced with 0. Once I got this, I should update my original column. df of reviews equal to this. After this is done, let me print the original data frame. Now look at this reviews column. So in this, all the positive are replaced with 1 and all the negative are replaced with 0. Okay. So here I'm going to show df of review dot value underscore counts. Now when I run this, here notice there are 1 values are 317. These are all the positive values, and 0 values, negative values are 71. Okay. So this is how we have converted this reviews also into numerical. So let's focus on the other columns. Let's focus on other columns now. So now we are going to focus on monthly income. Okay. df.head monthly income. Let's focus on this monthly income column. So here I'm going to do df of monthly income, dot value underscore counts. Now when I did this, here you'll notice that what all types of values are there in monthly income. No income is there, and then there are 187 values of no income. 25,000 to 50,000, there are 69 values. More than 50,000, there are 26 people who are earning more than 50,000. And then there are 45 people who are earning in between 10,000, 1 to 25,000. Below 10,000, there are 25 people. Okay. So now here I'm going to create a dictionary for this. I'm going to create a dictionary that income dictionary. I'm going to create an income dictionary is equal to, now here I'm going to create no income. Here no income should be shown as 1. All the people with no income, I want that value to be shown as 1. And below rupees 10,000, this value should be shown as 2. Okay. This value should be shown as 2. So 10,000, 1 to 25,000, all the people who are having the value in this be shown as 3. And then here next 25,000, 1 to 50,000, here this people should be shown as 4. Should be shown as 4. And then here more than 50,000. More than 50,000. I want this value to be shown as 5. Okay. I want this particular value to be shown as 5. Here I've created this dictionary. Once it is created, what I'll do, here I'm going to do df of monthly income, dot map. Inside this, here I'm going to pass monthly dictionary. Okay. So now here, let me run this. Here, did you see 4 means what? 25,000 to 50,000. 4 is being shown. Okay, more than 50,000, 5. No income people are being replaced with 1. Okay, here I'm going to replace my original column df of this equal to this. Now, after this is done, let me look at the original data frame. Okay, here I'm going to print this df. Now, when I run, here you look at this. What is happening? Where is monthly income? Did you see the monthly income column has been fixed? Okay, monthly income column has been fixed here. So we don't create dictionary related. So here I will show you. I'll show you, Kirti, what it will do if we don't pass. Okay. At last, I'm going to show that. So now education qualification is there, and the next year in this education qualification is there, and what else is there here? That's it. Last education qualification is there. Okay. We are almost done. So now for education qualification, what I'm going to do here, I'm going to do df of education qualification. Df of education qualification dot value underscore counts. Dot value counts. Now when I run this, here you are able to see people who have graduated. There are 117 people who have graduated. Postgraduate people are 174. PhD people are 23. People who are doing school are 12 people. Uneducated people are 2. Okay. So now let's create this. So I'm going to create a dictionary for this one. So here I'm going to do, here I'll do education dictionary. So now uneducated people, I want them to be replaced with one. And then school people, I want them to be replaced with two. And then PhD people, I want them to be replaced with three. And then postgraduate people, I want them to be replaced with four. And then graduate people, I want them to be replaced with five. Okay. And then what I should do here, DF of education qualification, DF of education qualification dot map. For ordinal column, you should use map method. And then inside this, I'm going to pass education dictionary. And then here I'm going to simply update my original data frame also. Let me run this. And then after this here, I'm going to print my original data frame. Now, when I did this here, did you see education qualification also is now converted to education qualification is also converted to numerical. Okay. Right. So here we have converted all the data into numerical. Okay. Are we left with any column? Did we leave any column here? Can you guys see any column which is text? Exactly. Order status. This is the last one, right? Let's complete this. Here, what I'm going to do, here I'm going to complete this as well. So here I'm going to do df of order status dot map. I'm going to leave it like this only. I'm not going to pass any dictionary. Now when I run this, see it is giving me error. I cannot leave it empty. Okay. I cannot leave this empty. I have to pass a dictionary. Okay. In this order status, I'm having the values of yes or no. So here I'm going to have order status dictionary. Okay. In this, yes value will be shown as 1 and then no value will be shown as 0. Okay. And then here I'm going to pass this order status dictionary into this. And then here I'm going to update my original data frame. After this, here when I print this df value, here you're going to see in this, all the values are now converted to all the values are converted to numerical. We have fixed the missing values. We have fixed the outliers. Okay. We have removed unimportant columns and we have also learned whenever we are having any, whenever we are having any missing values, how do we fill those? Okay. If there is an outlier, we are going to use median. If there are no outliers, we are going to use mean. Okay. All this we have discussed. Okay. So guys, any questions, any doubts in this? So we have learned how to get our data ready so that it can be sent to a machine learning model. Okay. So guys, we have this marks the end of this workshop where we have learned how to clean data, how to get our data in a proper format. Okay. Any questions, any doubts? Yeah. In tomorrow's class, I'm going to tell about mode. Okay, tomorrow morning we are going to talk about mode. I'm going to still discuss more things, but today it's enough. Can we convert ordered state directly? No, no. You have to pass one by one. You have to pass one by one. Okay. Yeah, I'm going to talk about just give me